This animal should not look possible. A hummingbird freezes in midair beside a red flower, wings blurred into transparent arcs, body hanging in the air as if gravity forgot to pull it down. Its chest pulses rapidly. Its wings move too fast for the human eye to follow. Its heart races near the edge of what biology can survive. Imagine 1,200 beats per minute. For a human, that would be catastrophic. Your body would fail. Your heart would not be a symbol of life anymore. It would become a warning sign. But this bird keeps flying. It can hover like a helicopter. It can fly backward. It can rise straight up, drop straight down, turn sideways, and even flip upside down for a brief moment. It lives beyond ordinary physics. Welcome to the high-speed heart. Hummingbirds belong to the family Trochilidae, a family of living sparks found only in the Americas, from Alaska to Patagonia, from cloud forests to deserts, from tropical valleys to city gardens. Hummingbirds have evolved into some of the most extreme flying machines on Earth. There are more than 360 species. Some are smaller than your fingertip. Some live in the Andes, where the air is thin and cold. Some visit backyard feeders just outside our windows. Others look almost mythical, like the sword-billed hummingbird, carrying a bill longer than its own body. But all of them share one truth. They are built around speed. The first miracle is flight. Most birds flap their wings up and down, generating most lift on the downstroke. But hummingbirds do something different. Their shoulder joints allow the wings to rotate in a wide arc, tracing a figure-8 pattern through the air. Lift comes on both strokes. Downstroke. Upstroke. Again and again. That is how a hummingbird can hover perfectly still in front of a flower. It is not simply flapping. It is sculpting the air from both directions. A helicopter tries to imitate hovering. A hummingbird was born into it. But control has a cost. And the cost begins in the heart. Blood must move immediately. Muscles must fire constantly. Mitochondria inside the cells must turn sugar into motion almost as fast as the bird can drink it. The chest muscles burn like engines. Nectar becomes instant fuel. Flight spends that fuel violently. A hummingbird has one of the highest mass-specific metabolic rates of any warm-blooded animal. Scale that metabolism up to a human body, and the comparison becomes absurd. You might need an impossible amount of food every day just to keep the machine alive. Not for sport. Not for exercise. Just to exist. For a hummingbird, hunger is not a feeling. Hunger is a countdown. A few hours without fuel can be dangerous. Every flower is a fuel station. Every sip delays starvation. Every lost feeding opportunity matters. That is why hummingbirds fight. They chase rivals away from feeders. They guard flowers. They spiral through the air in aggressive battles. What looks like tiny anger is actually survival economics. Fuel means life. Dominance protects the engine. And as they feed, They also become part of a larger system. Their bills enter flowers. Their faces collect pollen. They fly to the next bloom. The engine becomes a pollinator. Hunger shapes ecosystems. The flower feeds the bird. The bird moves the future of the flower. But the beauty of hummingbirds is not only speed. Look at the throat. A male hummingbird turns his head, and suddenly the gorget ignites red, violet, pink, green, optical. Then, with another tiny movement, the color disappears into darkness. This is not ordinary pigment. This is microscopic architecture. Inside the feather, layers of melanosomes, keratin, and air interact with light. Some wavelengths cancel, others strengthen. The result is structural color physics painting the feather. Change the angle. Change the color. In shade, the jewel sleeps. In sunlight, it becomes impossible. A head turn becomes a signal. The display is made for the female's eyes. In courtship, speed and color combine. A male dives in a shimmering arc. Flashing his throat at the exact moment, light strikes the feather. Timing makes the flash electric. Beauty, here, is not decoration. It is optical engineering. Then comes one of the strangest designs in the hummingbird world. The sword-billed hummingbird. In the misty cloud forests of the Andes, this bird carries a bill longer than its body. Even resting becomes strange. The bill looks like a burden, almost as if evolution went too far. But the flowers are strange too. Long, tubular, deep. The reward is buried at the base. Shorter bills cannot reach it. The sword reaches hidden nectar. This is coevolution bird and flower shaping each other across generations. Longer flowers favor longer bills. Longer bills unlock deeper nectar. The two traits spiral together through time. One flower. One bird. One design. The sword is both burden and key. But every day ends with danger. At sunset, flowers close. Light fades. The fuel stations shut down. The tiny body perches alone in the cold darkness. A normal sleep could be fatal. The high-speed heart cannot keep burning all night. So the hummingbird does something extraordinary. It enters torpor. The body temperature drops from around 40 degrees Celsius toward the cold of the night. The heart slows dramatically. Breathing becomes barely visible. The bird may hang limp and still on a twig, looking almost comatose. This is nightly death. A controlled shutdown. Warmth becomes too expensive, so the bird gives it up for a while. Torpor is powerful, but dangerous. A torpid hummingbird cannot react quickly. A predator in the dark would find a body that is slow to wake, but without torpor, the bird may starve before morning. So every night becomes a gamble. Hours pass inside the shutdown. Then dawn returns. Light reaches the perch. The bird begins to shiver. Heat climbs back into the muscles. The heart accelerates, the machine reboots, and hunger takes command. It launches toward the first flower of the morning. Breakfast is emergency fuel. Sugar rescues the engine. By morning, speed returns. Now watch the tongue. For a long time, people imagined the hummingbird tongue worked like a simple straw, drawing nectar by capillary action. But high-speed studies revealed something stranger. It is not a straw. It is a dynamic fluid trap. When the tongue enters nectar, the fork tips open. Then the sides curl and zip shut around the liquid. Nectar gets trapped along the tongue's surface. The tongue retracts into the bill in milliseconds. Open. Trap. Retract. Reload. Again and again. The bill helps unload the fuel. The tongue reshapes itself. The flower barely has time to move. Feeding happens during flight. Wings and tongue synchronize. Heart, wings, tongue, flower, the whole system is integrated. Miss a flower, lose time. Lose time, lose energy. Lose energy, risk death. This is why the hummingbird feels like a beautiful glitch in nature. Every part is pushed to the limit. A relentless heart. Extreme metabolism. Rotating wings. Optical feathers. Specialized bills. Nightly shutdown. A fluid-trapped tongue. Together, they make the impossible routine. Even rain becomes an obstacle. Droplets strike the wings like tiny stones. Wind pushes the bird sideways. The wings correct instantly. Flowers can hide predators. Spider webs can become traps. A rival can steal seconds of feeding time. Every choice has physics. Every movement has cost. And still, some hummingbirds migrate astonishing distances. Tiny engines cross open water. Before migration, they must load fuel, building fat reserves inside bodies that normally live on the edge of starvation. Fat becomes emergency range. Then the tiny engine disappears south. The fuel race resumes elsewhere. Even human feeders change the equation. A clean feeder can help. A dirty feeder can harm. Sugar water must stay fresh. Better still, grow flowers. Native plants bring nectar, insects, and habitat. Because hummingbirds need more than sugar. They also eat tiny insects and spiders. Protein builds bodies, repairs muscles, supports feathers, and feeds growing chicks. The engine also becomes a parent. A female builds a tiny nest with spider silk so the cradle can stretch as chicks grow. Eggs smaller than beans begin a new life. Chicks gape. The fuel demand multiplies. The mother becomes a delivery system. New engines begin testing. Flight begins as instability. Soon, speed becomes necessary. This animal compresses extremes. A heart near impossible speed. Wings that break normal flight. a metabolism like fire, feathers that paint with light, a bill shaped by flowers, a nightly brush with death, a tongue that traps liquid, and all of it weighs almost nothing. Nature made a beautiful glitch. Science can explain the mechanisms. High-speed cameras reveal the wing beat. Transparent flowers reveal the tongue. Spectrometers reveal the shimmer. Sensors reveal the engine. But explanation does not diminish the miracle. It makes the miracle sharper. The naked eye misses almost everything. Every frame contains engineering. Every flash contains physics. Every sip contains survival. As the day fades, the hummingbird takes one final drink. The sun drops below the flowers. The fire must dim again. The high-speed heart prepares to slow. Warmth becomes too expensive. Speed surrenders to stillness. Stars turn above the tiny bird. The smallest engine trusts the night. Then morning demands resurrection. The bird shivers. Its eye opens. The heart accelerates. The wings return. And life restarts at full speed. Backward. Upside down. Hovering. Flashing like living metal. Drinking with a liquid trap. Dying nightly to live daily. It is not just cute. It is apex biology in miniature. Every part is pushed to the limit. And still, it looks effortless. Powered by a high-speed heart. Balanced on the edge of biology. The high-speed heart never stops for long.